Hello, welcome to the world of mathematics. Okay, I am with you. Solving inequalities. Hopefully you have something that comes to your mind for that. Less than, greater than, less than or equal to, greater than or equal to. And today we're going to look at multiplying and dividing. Okay, so this is what you want to put in your notebook under the table of contents. Okay, and get started so you can show me this in class that you are done with this. All right, we're going to start by just looking at a simple inequality that we don't even need to solve. I just gave you one. I said 18 is greater, it's the greater than sign, than 12. 18 is greater than 12, right? Yeah, that's true. Now, I just want to look at some things here. We're going to analyze this inequality. We're going to look at the operations, addition, subtraction, multiplication, division. See if any of these are sort of fishy with inequalities. So let's say we take this true inequality statement and we add a number to both sides. So let's say we take 18 and add 2 to it. And I keep this greater than sign, and then I do 12 and add 2 to that. Is my statement going to remain true? Well, this would turn out to be 20. This would turn out to be 14. Is 20 greater than 14? Yes. Okay. That's cool. So this is true. If we add a number to both sides, the inequality statement remains true. Like, Miss Everly, what the heck are you trying to say to me? Well, I'm just trying to analyze different operations with inequalities. Okay, so just hang on with me here. Let's look at subtraction. If I take 18 and I subtract, I don't know, say 8. Make it easy. I keep the inequality of greater than. I take the 12 and I'm going to subtract that same number, 8. Let's see what happens. 18 minus 8 is 10. 12 minus 8 is 4. Does my inequality statement remain true? Is 10 greater than 4? Yeah, it is. Oh. So this remains true. Okay, so you're like, okay, you must be showing me this because one of these is going to be false. Well, you might be right. So let's go ahead and try to multiply both sides by something. Let's say we multiply by, I don't know, 2. And I take 12 and I multiply it by that same number, 2. Is it finally going to be false? 18 times 2 is 36. 12 times 2 is 24. My gosh, Miss Everly, it's still true. Oh. But watch this. What if I were to not multiply by a positive number? What if I multiply by negative 2? Oh man, Miss Ebbs. 18 times negative 2, well, that's a negative number. Negative 36. 12 times negative 2 is a negative number, negative 24. So I ask you, is negative 36 greater than negative 24? No! It's not. Negative 36 is actually less than negative 24. To get this to remain true, I would have had to change the inequality sign around. So this multiplying, but well, actually I should not conclude false right away. We noticed when we multiply, let me erase those. Some of you are going to hate it because I'm going to leave some dots on there. When we multiply, 2 things happen. Sometimes it is true. And when was it true? When we multiplied by a positive number. It became false when we multiplied by a negative number, meaning we had to change the inequality sign to remain true, to keep it true, to keep trueness factor, to keep the trueness. You might be like, is that a word? You know, I don't know, but I'm using it. Okay, and I'd like to keep that on here, but I am going to, I have 5%. Let's see if I can keep going. I'd like to keep that on there, but I have to erase that. I need more room. What about division? What's going to happen with dividing? Okay, let's take an easy number to divide by, like 2. If I take 12 and divide it by that same 2, is my inequality going to remain true? Well, 18 divided by 2 is 9. 12 divided by 2 is 6. And 9 is greater than 6. It worked. It worked. So that remained true. But what am I going to do? What if we divided by a negative number? Then this would be a negative 9. That would be a negative 6. And is negative 9 greater than negative 6? No. It's colder. It's less. So, same thing happens here with multiplying and dividing, the thing that we're looking at. If we, nope, you guys cannot leave this video yet. If we, because you're in a video, okay, you're not in class, you cannot leave. If we multiply, well, actually here, it remains true. If we divide by a positive number, it's false. If we divide by what? A negative number. Okay, which means, what am I going to put here? We have to switch the inequality to keep what? The word I made up. Maybe it's not made up. Maybe it's really a word. The trueness factor. Okay? Okay, deep breath. Let's look at some of these. Okay, so these are ones that we actually need to solve, but we're not going to do the entire thing to solve it. We're just going to look and say, will the inequality remain true when we solve it? Okay, so here's one that you're used to solving, or you should be. We did this in class. To solve this, we're going to have to get rid of this plus 5. So what are we going to have to do to both sides? We are going to have to subtract 5 to both sides, right? Is that going to change the trueness factor of my inequality? No, I will not have to change it. So my answer will be x is greater than 20 minus 5, which is 15. That'll be my solution. Okay? If we look at this one, how do we solve this one? Well, we'd add 2 to both sides. If we add 2 to both sides, is that going to change? If we add 2 to both sides, is that going to change the trueness factor of my inequality statement? No, it won't. So my answer will be x. I'll keep that inequality because it remains true. If I add 2 to negative 5, I'll be at negative 3. Now, what if we look at these 3? This one, how would we get m alone? Well, the 3 is being multiplied with m, so I would have to divide by 3 on both sides. If I divide by a positive number, will the inequality remain true? Yeah, it will. So I will keep it, and my solutions will be greater than 33. Okay, let's look at this one. Negative 8 times x, less than or equal to 80. What will I have to do to get x alone? I'm going to need to multiply, do the opposite inverse operation of multiplication, which is division. Divide by negative 8. I'm dividing by a negative number, which means the trueness factor is gone. It's going to be false. In order to make it true, what do we have to do? We have to switch the inequality sign. So my solutions would not be less. No, no, no. They would end up being greater than or equal to 80 divided by negative 8, which is negative 10. If you don't believe me, don't leave yet. Another bell. So many bells. A solution that is greater than negative 10 would be like, let's say 0. 0 would be greater than negative 10. So if I plug in 0 right here, negative 8 times 0 is 0. And is 0 less than or equal to 80? Yes, joy, it works. Okay, last one, this one. What do you think? To solve this, what are you going to have to do? You're going to have to get rid of division by negative 2. To do that, I would do the inverse of division, which is multiplying, and multiply by the number I want to go away, negative 2. So I'm multiplying both sides of an inequality statement by negative 2. A negative number, which is going to make my inequality false, meaning I'm going to have to switch it for my solutions. So my solutions would be greater than negative 24. That was pretty quick. We're going to be practicing this in class. So I will see you there, people. No crying. Keep it in your math notebook. Take deep breaths. You'll be okay.